Last night? Yeah. All of it.
Yeah.
We might have missed a couple of spots. We got most of it. It's a nice little thing.
That last week, huh?
No.
They brought the recovery this week. Brought the recovery truck back to us. Easy way to just grab it like here. It's beautiful right now. It says it's supposed to get windy. Talked to Alex last night.
Just like with Buffy, they definitely need them, but they'll fire them.
Okay.
Power on. This gives you the selection between the primary or the backup transmitter. This wasn't on board ship in this position. We put it up here so the controller can monitor the commands that are going out. The CIC, the deck control. And then the thing on the right is the, what would we call it? The GPS tracking system?
Target tracking and control system.
He's calling it a target tracking and control system, but we actually only use the GPS portion. We don't use any of the uplink or downlink. Okay. The difference between the way it was operated on board the ship.
Okay.
If you look here, you'll see that this would be the CIC position on the ship.
Okay.
And this gives you the ability to have another control box. This could be active if we wanted it.
Okay.
But since we have, it would be useless for us. When Gyrodyne had it, they had tracking systems and display systems, and all of it was in the rear, so they moved back here to do a flight.
Oh, really?
An actual flight, yeah. They didn't do it from up there. Only for takeoff and landing, which is smart. This box here is your SRM-4, I think. What is it? I think it's, I can't remember now whether it's the 4 or the 6.
Data plate's on the far side.
Yeah. Receiver, which detects the transmitted frequency, decodes it, and sends it to the decoder, which is a monitor, really.
Okay.
Identical to what I have up front. What I did is I took the audio out of the receiver and sent it up, and I just run 2 decoders.
Okay.
So the technician in the rear can see what's happening, and the controller up front can now see what's happening, because before they relied on communications. We don't have that. The aircraft.
I see.
You can monitor the 3-phase 400 Hertz 115 volts, the 26 2-phase, and when the drone is turned on, you'll be able to see the 22 volt 3-phase. So you get a good idea of whether it's working, but you're also looking at those same voltages on the control monitor.
Okay.
It's kind of redundant. The other van doesn't have it. Okay. So just to the rear of the monitor, you have the transmitters. You've got primary, and backup, or 1 and 2, however you want to refer to them. They refer to them as transmitter 1 and 2 in the ship. And the interconnecting and switching is in this relay assembly right back here. This is an SRW4C system that has this one relay box that lets you switch control from the CIC, which is there, to the deck, which is there. If you visualize this van is made just like the boat.
Okay.
So
the forward deck controller is
that's the guy on the stern of the ship.
That's the deck controller right there, and then CIC is the controller that's got the foam cover on it right
It
now.
has the radar and whatever they use. So basically what we do is carry a spare deck control. But the point of it is that box allows you to interconnect either the 13 or the 14, which is the deck control is the dash 14. 13 is the little CIC control.
Okay.
No stick. I don't really know. Yeah, it was. I never used that function.
Okay.
I never had any. Now I did take the CIC control box and the transmitter and put it in a tracking system that we use to track other drones, and I flew from there. But I actually just had my transmitter and my encoder. My control box all tied together in that little radar pack.
What's the black box right there? I don't recognize that.
The old flight termination system.
Oh, I see. Okay. That's a range requirement. That's
Right.
not. Okay.
It's an add-on. This was done by Gyrodyne, I think. I'm pretty sure. Gyrodyne put that in. They had a single transmitter. When we did the Hellfire program, we had to go down. We had to go to the Air Force. So I had to make things a little nicer. This one, you have a dual flight termination system, and the automatic will switch if one goes off. I keep some monitoring equipment here so I can tell whether it's radiating. Frequency counter, voltmeter combination. What else? It's really pretty much identically to what you had on the ship, except not as big.
The transmitter switches around to be able to switch antennas.
Well, that's in your control box.
Oh, okay. That's on the front.
But the switches are right here. This will select either transmitter, and that selects either antenna.
Okay.
They radiated something on the order of 500 watts.
Jeez.
Yeah, it probably was more trouble for them than the 100 watt. No further than they flew, I don't know why they ever thought they needed 1,000 watts.
What about that box right there, the interconnecting box?
This box is a maintenance box mainly. It was added so the only way you could switch antennas and transmitters from wherever this was located on the ship was at those 2 points there.
Okay.
And so they added this box in the seat. This is the SRW4C.
Right.
If you go to the SRW4B that we have over on the white sand, the box doesn't exist.
Oh, I see.
The problem this introduced is you can now select here and get out of phase without one. So you can have...
You talk about the one that's on the wall above the CIC box?
Yeah, you have to make sure that you bring up a transmitter. What you do is you go to local control. You've got to make sure that you've selected that transmitter back here now.
Okay.
Otherwise, it's radiating into nothing.
I see.
So it was more of a headache. I saw what they call airframe change. They put some sort of notum they put out about that being a problem because those transmitters get you can damage them fairly easy by radiating at no load.
Oh, really?
Yeah. Easier than some, most. I mean, it's not a good idea to. And I have one more meter. I added a watt meter here going out of the van. I've got a lot of them, so I put me one more in just to monitor the port. I'm using the left antenna, which is the port.
Okay.
Monitor the power at that exit. So I'm almost at the antenna.
Okay.
It gives me a warm fuzzy about, because sometimes you might read a signal here and not get through the switch.
I see.
So this gives you, if you're in the line, why they didn't do that, I don't know. They did it in so many other things. Why they didn't give themselves a power sample somewhere near the antenna.
Well, the antennas were high on the ship.
Yeah, but it wouldn't have been that big a deal to do. Yeah, they sample it in here for power. That's how they get the readings.
Okay.
But the important thing that you learn after 30 or 40 years of doing this is that what is out at the antenna is what counts.
Right.
All these readings are useless if that reading isn't there. So, and that's pretty much the way it works. It's almost identical to the ship, with the exception of the way it's physically located. I don't know where that bear drive was on that boat. I assume
It was in the hangar. It was in the hangar on the forward bulkhead.
Okay, then the cabling for how it ties together is up here. Our umbilical junction box and the auxiliary power unit is tied in up there.
Okay.
If you look under the van, you'll see all kinds of cabling.
Yeah.
They had to have that too. This is what it takes to tie that box into the system.
Okay.
Every channel has a relay. You can select this box or that box. You know, that relay, that's magic back there. Okay. You start out, the URW-14s generate a UHF command carrier frequency.
Okay.
Which is modulated by IRIG 16, which is 43 kilohertz.
Okay.
Or thereabouts. I'm not sure I don't know the exact frequency, but it's around 40
Okay.
kilohertz. In order to develop a digital code, they take that center frequency of 43 and they move it 2 kilohertz either side of center.
Okay.
The lower frequency equals a 1, for instance, or it might be a 0. I can look it up. Or and the upper frequency would equal the opposite. So
Okay.
you got your 1s and 0s. Now we got our digital logic, right?
Okay.
Okay. All of this equipment here has digital data keys or words. I'm trying to think of it's an identifier pulse. Everything is done in time. So when, for instance, the collective pulse comes up to the encoder, it's sent into a shaft encoder, and then it's outputted as gray code, it's called. But it's actually a digital representation of the value that you've dialed in to this knob or this encoder. That in turn is turned into like a 10-bit word. 10 bits of 1s and 0s. So you either got a 1 condition or a 0 condition. Well, that is now sent into the URW-14, and we do the same thing. We drive, we take our 43 kilohertz and we modulate the URW carrier with that 43 kilohertz, high and low, high and low.
Okay.
1 and 0, 1 and 0. When this thing is radiating, that starts receiving it. That receiver on the drone is receiving the carrier.
Okay.
It sees it, it syncs up to it, it has a certain code it's looking for. When that code comes in, it's called the address.
That's the address that's also on the decoder, on the...
That is the address.
Okay.
When that address matches up,
right,
it then starts, it times itself. It starts measuring the time between the pulses, and it knows what channel you're sending.
Okay.
Because remember, I told you we send identifier pulses up. Well, they are sent in a specific time relationship to the address.
Okay.
So when that pulse comes up, that's at the collective time point.
I see.
The data is passed through. This thing out there receives it. It simply takes that and converts it right back to this position. In the autopilot, it equals a AC voltage, 400 hertz voltage. It varies from, say, 1 to actually about 2 volts to 7 in the collective channel. But that's all it really is. It's a digital representation of an analog signal.
Okay.
And you can probably say it a lot better, but you can't make it much simpler. I can't think of nothing. The big problem with this system is it's slow. We use one 1 millisecond pulse.
Okay.
Now in a millisecond in a normal, say a modern PC, you would have 3 billion pulses.
Yeah.
You know, maybe not 3 billion, but something.
Okay.
A large amount. So this is a real, so you can hear it. You can hear it clicking.
Oh, really?
You can go out there and hear it.
Out on the decoder? Okay.
Yeah, we listened to that, and that's one way they confirmed it. In a nutshell, that's about the only thing they really did with it. Years before this, they used a single tone, for instance, would be a discrete channel.
Okay.
You transmit, for instance, a flight termination. We use iRig 1, iRig 5, and iRig 7 to turn off the fuel valve and stop the drone if we have an emergency situation.
Okay.
This unit is called a Gyrodyne,
Okay.
and it provides the prime mover for a generator that's used on the aircraft. This provides auxiliary power when you round the phase without the rotors turning. There's no power available from the aircraft.
Okay.
So this is used in lieu of that. Once the aircraft is started, the drone is switched over to internal power, and then it's an identical generator on board the aircraft that provides the 3-phase 400 hertz power, which is then converted to everything that's needed for the system.
Do you ever adjust that handle at all, or is it set once you got it?
Pretty much stays where it is. I like to see it about 405 hertz.
Is that what that indicator is right there?
Yeah,
or
but
what?
I go by the one in the room.
Right.
I have a frequency meter inside that I use.
Okay.
That power is sent to the junction box. I can't really tell you where these were on the ship.
These interconnecting boxes?
Yeah. This is a drone shackle that holds the drone down
Okay.
until the controller is ready to launch. These are the J boxes. Each one services one umbilical. This box is the 832. Now you would be able to see that if you were, this supports the engine umbilical.
Yeah, we've got those on the Kennedy. Yeah.
Now there's 2 of these on this particular. Why the Gyrodyne did that, I don't know, but this one supports the avionics umbilical.
Okay.
The other one is a special projects box. Gyrodyne put it in so they would have another point of entry into the umbilical cable.
Okay.
And I'm not totally sure I know why they did that. Nothing but terminal boxes.
Okay.
You tie an umbilical into the signals coming from the control monitor.
Okay.
And from the power device I just showed you over there.
Right.
And then you've got the start rectifier. In order to get the engine started, this black box provides a source of 28 volts to start the engine. You need about a 400 amp capability. I believe it's a 600 amp unit.
400 amps? Whew.
Yeah, you might start it with less, but if you get too low, you're not going to get enough RPM. You might start getting hot started.
Yeah.
So it's better to be, the more the better. Really.
Okay.
Anyway, that is all fed into those junction boxes, which are tied to the control monitor, and you control the application of power to the aircraft with the control monitor. And then, of course, the umbilicals feed it out there. And that's pretty much the interconnection of the van to the aircraft. QH-1 said they finally moved it all the way to the back.
Yep. But
So they-
look
give
good
me my
on
bag.
all this now.
Yeah, I'll get it. Okay. Just for that one.
Well, this is supposed to be exactly where it would have been. Well, yeah, but the only thing between you.
But see, the thing is, you got all that stuff sitting beside it in the way. Right now, where it is, you get a good lock, but when it points out this direction, then you don't. And it's there, they just don't give it. Try and give it the bird. And they're coming.
I walk around and look, there's that cover.
Although we know one thing, it'll pick up 2 500-pound inert bombs in the middle of the summer with no problem. And
Really?
hover out a ground effect with them.
Wow.
Yeah. Plug in days. Yep. Anyway, they're putting the oil in. There's no color in it at all. Fired it up. Anyway, most of them
Hey, how's it going? All right. Different guy every day out here.
Pretty much, huh?
Was it whoever gets the short straw's got to come out here? Joe, was the last time he was out here? That's what he's saying, is that's the news in the other. He said, no, it's a different guy each time. Alright, that's cool. We're still green at 9?
Yeah.
Alright, whenever you're ready, Steve.
Okay.
Don't we? Can it lift that plate? They said, ain't no way it can lift that. What the hell? I put it tied down on the plate. The way we went, we've been doing it. That was in the 70s. And all of a sudden we became mobile. It didn't matter where they were. Yeah, we could go pick the spot. You know, instead of having to find a pad, you had to fly out of that. And the main reason we were doing it, I was the only controller. So they had been, Beach had had the contract before, they'd been launching on the other side of the road and flying it across, handing it off. Now we're getting ready to do our pre-flight checks. We're going to verify that we can shut the fuel off through all 4 methods, through the umbilical cable, the transmitted engine off, a transmitted destruct, and arming the timer and an automatic shut off 5 seconds after the timer's armed. We're going to verify that we've got a cyclic going to the decoder box. We're going to check the baro tube, and we're going to verify that we do have igniters.
What is the cyclic? Is it a cyclic lock?
No, he's just going to give us some cyclic command, and I'm going to listen to the decoder, and I should hear the relays chattering that it's receiving a signal coming out.
Oh, I see. Okay.
What we just did was load check the destruct battery, be sure we got enough power to actually destruct the airplane if we need to. Hopefully not.
QH-50.
When we unlock the cyclic locks, when he actually gives me an engine off command, it should lock the cyclics before it will take the engine off.
Those the gyros winding up?
Perfectly. And now it's getting windy. It's lunchtime.
Oh dear, yep. Oh, that's a little triangle thing, huh?
Like got a pretty strong wind up there. See it's chopping.
You know what I'm saying? We would normally break out right at the end of the straight run. That's when you would break out. All you try to do is get that bigger radius. Yeah, just fly the profile. And then like I said, it'll take 1 or 2 runs to figure out what the winds are doing to you.
The winds are picking up.
Of course, it's flight time. It was dead calm when we got out here this morning.
Yeah, I know. This morning. Pretty calm.
Whoa, there's a big one.
56.
Oh God, really? getting windy out here. That's not from the rotor downwash.
That was back when...
So Kenny, you're pulling the gyros for transport?
Yes,
What
sir.
do they call themselves? The Outlaws. Willie Nelson.
Out here in the
all them
desert,
guys.
we beat them to death.
Mm.
Waylon Jennings mainly, Willie Nelson, they were all called. They were drunk today, your mom got out of prison. They pick her up in the rain. Boy, there's been a lot of beer drank today.